Hi, I'm Richard.
Richard is a senior product manager on the Autodesk Fusion team, and he is currently looking after the constraint components functionality in Fusion.
The title of the question is Interrelated Hinged Joints. This is my folding A-frame cart. It has 5 hinges connecting the sub-assemblies, which move together when opening and closing. How can I add joints to the hinges so they will all move when I drive one joint? Brilliant question. Thanks so much for doing so. Really got me thinking, this one did. So I tried to really simplify it. Where you put joints shouldn't technically make any difference. Joints could be at the very bottom of the assembly, at the very top of the assembly, scattered throughout. They will all compute correctly at that top level assembly. What I would say, though, it makes a big difference for your own personal sanity. So look, I've got here my hinge repeated. My revolute joint is in that hinge. So if I isolate this here, you'll see that I've got that joint in there. I'm going to go and drive that, and I can move that in there. So for me, that's the clearest way to do this. What I think about is, if I was to strip this down into its components, what's the lowest level that joint would survive? And it's at this level here. This would be. So again, without really seeing that CAD model and interrogating it, it's hard to tell, were the leaves of the hinges bolted on, or were they part and integrated? So it's hard to exactly say, but I would say strip that assembly down like you're disassembling it, and I would put the joints at their lowest level. And then one thing I didn't see mentioned in that post was the word motion links. And I think that's what could be going on here, because it's about driving one joint. So if I join this one at 105 degrees, I can right click and go drive joints. I could have double clicked it. There's a few ways to drive joints. And I move it. You'll see the assembly move, but it might not be in a predictable way. You can see, there we go. I've got it to fold on itself, because we're just computing solutions as we go. And it's one of those. There are multiple solutions that could happen at any one time. So let's cancel that. What we're going to look at now is a motion link. So under assemble, I have the ability to do motion links, and I can link that joint and that joint together. So what's going to happen now is when I move this, for example, they have a one-to-one relationship. So as the one joint decreases by 1, the other joint decreases by 1. That could potentially be the solution there. Again, without looking at the CAD model, it's hard to say exactly, but I think this would be a good place to start, is if you have something that you want to move together, putting that motion link in place can be a real one for it. And here's a nice demo that I did for a project a few weeks ago with a planetary gearbox. And just to show you how fun motion links can really be, what we've got here is a one-to-one relationship between the planetary gears and this carrier in the middle. Carrier in the middle of that planetary gear, and that carrier has 4. So if I turn the carrier off, you'll see sort of what it's doing. Again, I'll just quickly isolate it there. You can see how it's pivoting around. And then the key thing here is between one of those and then the center joint, we have the 3-to-1 relationship. When that joint moves by 1 degree, that joint moves by 3 degrees. And that's what gives us the gear ratio there of 3-to-1. So again, we've always got us 3D print stuff. So we've even got that little 3-to-1 gearbox printed off there. So as these outer gears move 1 rotation, that inner gear moves 3. So that was actually quite a satisfying way to spend an afternoon, was getting all that modeled up, working out all the module and the teeth numbers to get it what I wanted to in such a small package. Doing double herringbone gears is always a fun one. The advantage of a double herringbone gear is it doesn't pull out side to side as it's locked in. So I'll stop on that tangent there. But back to the original question, the key there is put the joints as low as you can in the assembly. It will make duplicating things easier. I put that joint in once, and then I copied and pasted that hinge, so I've got it multiple times. I haven't had to redo it all the time. And it also just helps with that fault finding. I find that it's at its lowest level. If I had a sub-assembly just of the base table and that bar, the joint would be there. If I didn't put the joint up until the top level assembly, my sub-assemblies wouldn't move. So that's why I would say, do your joints as low as you can, and then they'll walk up through the sub-assembly. Because that's what's happening in the real world. I'll stop there and I'll let everyone finish off on their day.